So the question is, how do you get from a faceted STL file, from a triangulated mesh, to a result in Fusion 360 that looks this smooth? This came from a scanned landscape, and this here came from a head scan, a head sculpt. And this looks really smooth. It doesn't look faceted. So the question is, how do we do this? The usual answer is often, well, just import the STL file into Fusion 360 and then in the mesh workspace use either the remesh or the reduce tools to reduce the face count. And the face count of this STL mesh is already over 300,000 faces. And even if I would use the tool, in this case, it doesn't even work because the mesh has a problem. It has duplicate faces and duplicate vertices. So not only doesn't it work, if you do reduce the face count, if you would actually be able to do this, it would remove that much detail that the mesh would pretty much become unusable and wouldn't resemble the original result. So the question is, of course, how do we do this? So the first thing we need is actual STL files. And the terrain mesh file comes from an online tool, and I'll link to those websites that I'm going over here. I'll link to those in the description below. This tool allows you to select a specific landscape, arrange here, define an area, some settings here, and in the end, when you click on export, it'll create an STL file that you can download. The head sculpt I got from the Artec 3D scanner website. They have a section with 3D scans where you can download scanned 3D files in STL format. I'll be using 3 different softwares to solve these problems. The first one is Meshmixer. It's a free software also created by Autodesk. It's not open source, but it's free. The next one is InstantMeshes, which is a very valuable tool. And another software that I use frequently is Blender. So with that out of the way, let's get started. So here we have Meshmixer, and let's start with importing that head scan. And that is here. There it is. So inspecting this head scan, I'm noticing these 2 parts here, and I really don't want these holes here. So I'm going to remove these holes in Meshmixer. That's here in the select tool, and I want my brush a little bit smaller, maybe like this. I'm going to select this area. That's okay. I'm going to select that area. And then I edit and erase fill these areas, and that's exactly what I want. I also don't exactly like the orientation here. I'm going to go into the transform tool, change this to world frame. And then I'm just going to rotate that and translate that the way I would like to have this oriented. All right, and that's already all the things that I would want to do in Meshmixer. And even if you'd be happy with the way this looks in Meshmixer, one reason to need to get it into Meshmixer is because the next tool only accepts OBJ files and one other format, and we need to export this as a .obj file. And I've already done this. So let's go to the next step. The next thing we need to do is we need to create a quad mesh. We need to remesh that triangulated mesh into a mesh that consists only faces with 4 sides. And my head sculpt is here. And this tool is fairly straightforward for these sorts of objects. I've opened the mesh. The target vertex count is determined by the tool based on the mesh information that it finds. And I click on solve once, I click on solve twice. It generates a preview of some sort of mesh. I click on export mesh. Now here's the important thing. We want a pure quad mesh. And I click on extract mesh, and that shows me how that mesh looks like that is going to be extracted. And in this case, I don't believe that is a fine enough mesh to convey all the detail that can be seen in the STL file. So what I'm going to do, I'm just going to override this target mesh count, go maybe to 10,000, accept this with yes, and solve again twice. Click on export mesh, pure quad mesh, and extract mesh. And this also looks faceted, but we have a quad mesh. And that's what we want. And the reason why we want that is we want to convert this into a T-spline in Fusion 360. And that only works with a mesh that has either mostly quads or is a pure quad mesh. And in this case, I'm also applying one, maybe two smoothing operations or iterations. And if I click again, we see that this changes the geometry and topology of the mesh layout. And then we can basically save it out into a mesh. And that would be another .obj file. So with that completed, we're going to go back into Fusion 360. There are two ways to import a mesh and convert it into a T-spline. The first one starts with turning off the timeline, importing the mesh, converting it into a T-spline, and turning the timeline back on. I'm not going to do that. I'm just going to insert the mesh and pick my head sculpture mesh that I created in InstantMeshes, rotate it into my preferred orientation, and here's our mesh. So the next step is that I need to create a little T-spline and convert this mesh into a T-spline. And it'll take a little while. All right, here's our T-spline. So we now have two bodies in our file. One is the actual mesh and one is the T-spline. And this T-spline doesn't look smooth. It looks sort of faceted and flat shaded. And the reason for that is there's actually a problem with this mesh. And that can happen. So if I click on Finish Form now, it won't do it. It tells me, hey, there's something wrong with the topology. And I'm going to close this out. I say Return. And in these cases, it usually helps when we click on Repair Body. Select the body, and then Fusion 360 actually shows us in red where there's a problem. So down there is a problem, and in this case I'm just simply click on Auto Repair, and that also will take a little while. All right, and now that has changed to a more smooth display, and I can click on Finish Form. And here is my completed solid body. So that's a BRep. And in essence, all these little patches here, they're NURBS patches, non-uniform rational B-spline. So that's also the difference between a mesh. A mesh has a finite resolution. An STL mesh has a finite resolution. And due to its triangulated nature, it also doesn't have topology in a mathematical sense. And a NURB surface is a mathematically precise description of a surface with no finite resolution. And that makes it very suitable for working with it in Fusion 360. So now you can basically go ahead and use all the modeling tools that you have here in the model environment in Fusion 360 work with on this object. So the next object that we're going to try is that landscape. So as I said earlier, that landscape already has a problem, and the problem is that it has duplicate vertices, and that is something that we are going to fix with Blender. So when Blender starts, and this is Blender 2.79, pretty soon Blender 2.8 will be released, and the user interface is a little bit different. Never mind though, I'm going to work with 2.79. So I also change from perspective to orthographic mode and insert my STL file. Import STL. So then I'm going to press the N key and click here on the scene tab and change this. Well, the default is usually nothing, but I change this to millimeters. So when I export the STL file, it'll be, well, actually I'm going to export an OBJ file, but it'll have the right scale. Then I'm going to also change the clip to 10 meters. All right, so I hit the tab key and go into edit mode, and we can see there are 690,000 edges in there, 395,000 faces, and there's absolutely nothing that we can do with this mesh in Fusion 360 other than reducing the face count. In a way that would totally eliminate all the detail that we have in this mesh. So the first thing that I want to do, I don't really want that box nature in InstantMeshes. So I'm just going to simply delete. First of all, I change this to through select. It's similar to what you do in Fusion 360. And hit the B key and box select all the vertices here on the bottom. Because all these vertices belong to all these faces here that define this box around the object, when I delete these vertices, I completely delete the box on the bottom. So that leaves us with this landscape STL. But as I mentioned earlier, this STL has another problem in that it has many, many duplicate faces. So again, I hit the, let me show this again. I hit the tab key to go into edit mode with the object selected. I hit the A key once or twice to select everything. Then I hit the W key and select remove doubles. And we can see here in the top that it removed over 50,000 vertices. So now all these duplicate vertices have been removed. So another thing that I want to do is I want to actually scale this down. I don't want this landscape to be so tall. So I hit the S key for scale, the Z key to limit this into the Z direction, and maybe SZ a little bit more. All right, that looks okay. And then there's another thing that I want to do. Oops. I want to flatten this area. I don't want this in my final object. This can also be done in Meshmixer, but I really want to do this in Blender. Blender also has a sculpt mode, and in this particular sculpt mode, what I'm going to do, there's a flatten brush here that I'm going to use, and I make that a little bit stronger, and I limit this to the Z-plane. So with that, I can actually flatten out this area here, just brush over it. And there's a flatten brush in Meshmixer as well that would do this kind of stuff. So if you want to remove something from the STL mesh before you quadrify it, you can do that in Blender as well. So just use the tools that you have at hand, and if a tool doesn't do what you want it to do, well then just use another tool, right? Okay, so now we have flattened that area, and with that we've done everything that we want to do in Blender. And I can now go ahead and export this as a .obj. And again, I've done this before, so now it's going to go back into InstantMeshes. So I've opened our landscape.obj file already, and this is still triangulated. So yet again, I need to simply solve, click solve, and it provides me with a preview of how that quadrified mesh looks like. I personally think this is this would probably be okay. So this looks pretty rugged, I'd say, and there's some pretty sharp corners in there. So I'm going to apply some smoothing iterations and click on Extract Mesh again. And that looks okay to me. So again, I could just save this out into yet another .obj file. And that OBJ file we would now import into Fusion 360. So back in Fusion 360, I would do the same thing as I did with the head sculpt. Insert mesh, and where it is, landscape IM OBJ. And here it is. And now, yet again, I'm starting a little T-spline. Select that surface, that STL file here in the viewport, right-click, and click on Convert, and just convert it into T-spline. This takes a little while because it's a pretty dense mesh. So this mesh looks actually very smooth, and that means if I now click on the Finish Form button, it should actually work and convert it into T-spline. Into a NURB surface. And that's it. That's our final NURB surface. And there it is. So I'm going to change the display mode really quickly to show one other thing. I change this from shaded with edges to just shaded, and we see these strange artifacts here. And no worry, these are just visual artifacts in the viewport that have to do with the viewport code in Fusion 360 and the way it tessellates these surfaces to make viewing them easier. Sometimes it leads to these artifacts, but if you right-click on the body in the viewport, not in the viewport, in the browser, and change the display detail control from adaptive to fixed and to high, then these artifacts in the viewports will go away, and you end up with that nice surface here. What can you do with that surface? Well, as I showed earlier, that disk that I did, it's actually fairly simple. You can create a sketch now. And use all the tools that we have available. Let's give that 15 millimeters. Pull that back down a little bit. So that's a solid body here, and I can basically take the surface and split the solid body with that surface. Oops. So there it is, there's my disk. Then I applied a little fillet here. And well, I also applied a fillet to this edge here. But let's talk about that for a moment. That isn't so trivial, because there's a good chance that if you apply a fillet too large, then Fusion 360 will not do it. So it applied a 0.2 millimeter fillet. But for example, a 0.5 millimeter fillet might fail. And it should give us an error message down here. So 0.5 is too 0.5 is too big, and that has basically to do with all the very small radii and the curvature of all these NURB surfaces that you have here. So there are two things that in the solid modeling area probably won't work with these sorts of surfaces created from STLs. One of them is shelling. That almost always fails unless the surface is less detailed than this surface, and surface offset and filleting. That is very often going to fail. But other than that, you can use all the solid modeling tools that are available and work with these surfaces.